Metallic Bonding by Christine, Jackie, Jasmine, and Miriam.
Exactly what is metallic bonding? As the name suggests, it is a chemical bond between two metals. Metallic bonding displays unique characteristics such as conductivity, malleability, and more.
Metallic structure. The giant metallic lattice is one of the structures used to explain the properties of metals. This model consists of delocalized electrons and immobile positive ions. With a structure like so, the electrons act as a glue, keeping everything together. As you can see, this sea of electrons diagram displays the positive ions and free-flowing electrons. As the metals do not have strong hold on their valence electrons, they drift further away. This allows electrons to be shared with multiple atoms. When bonding occurs between metals, the theory named molecular orbital theory comes into play, which depicts the properties of metals more accurately. The densities will combine to form a molecular orbital. When the two atoms join together, they will form bonding, non-bonding, and anti-bonding orbitals.
The metallic bond can weaken if the metal is put under extreme tension for a long period of time. However, to strengthen a metal, it is combined with another element to create an alloy. The combination creates a stronger bond, preventing any breakage. For instance, bronze is a combination of copper and tin. Moving on to properties of metals. They have a high boiling and melting point. This is because the bond between metals is very strong. For the metal to melt or boil, the temperature must be able to weaken or break the bond. An example of a metal with a high boiling point is tungsten at 3,422 degrees. Metals are also good conductors of electricity. This is because they have free-flowing electrons. Metals with one free valence electron are better conductors, as the electron faces less resistance and can easily carry the current to other electrons. The diagram below displays an electric current. Metals are also good conductors of heat. In a metallic bond, positive ions are packed closely together and are constantly vibrating. When heat is added, the vibrations speed up, passing on energy to other ions. This process releases heat. Metals are malleable and ductile. This is because the delocalized electrons are able to freely move within the structure. When a force is put on the metal, the electrons will simply adjust by displacing one another, which results in a deformed metal.
Real-life implications. Metallic bonding is very helpful as it is used to make many things out of metal that we use in our daily lives. For example, copper. Since it is malleable, it can be drawn into thin wires. The wire has electrons from the valence shell of a copper atom, which allows electricity to be conducted. Since the electrons move freely within the wire, it allows electricity to be created. Aluminum is another metal that can be used to make aluminum foil. Aluminum, since it is malleable, can be reshaped by being pounded. When aluminum is hammered into thin sheets, the electrons quickly rearrange themselves to form a new shape, and this is due to the metallic bonding, which allows electrons to move freely to rearrange. Gold can be reshaped since it is one of the most malleable metals. Gold is used to make jewelry such as rings, earrings, and necklaces, and this is due to the positively charged ions, which can rearrange themselves in order to form their new shapes. Cooking utensils like pots and pans are made by various metals like iron, nickel, tin, and more. When energy is added to the metal, the particles start to move faster, causing them to collide with one another, which transmits heat. Metallic bonding is used to make solar panels. The panels consist of tiny crystalline silicon cells, which are basically made from silicon. The cells are semiconductors, meaning when the sunlight hits the panels, the light is absorbed, which increases photoconductivity. In other words, the absorption of electrons increases conductivity, allowing the sunlight to be converted into electricity. LED lights, also known as light-emitting diodes, are light bulbs that are made from aluminum gallium arsenide, which is a semiconductor material. The metallic bonding allows electrons to move through the material, which is then converted into light. LED lights are used for many things that are used very commonly, things like traffic lights, TV screens, billboards, and much more.
Stay tuned for part 2.
Created using Powtoon.